Hello again. This is Mr. Dodd. I am talking about limits today. Just a brief intro to what we are talking about with limits so that we have some background. This should be the second video in a series. The first one was background information. This one I'm going to give you just an overview, and then we'll go through the learning targets one at a time. First off, limits overview. What you'll see on your paper a lot is this notation right here. The way you say that is the limit as x approaches c, so the limit, Lim, as x approaches arrow c of f of x, or whatever your function is. And most of the time, to be honest, you'll see x squared plus 2 or whatever the function is in that spot. Sometimes you'll see f of x. This c is just some constant. It'll usually be a number. So what is the limit as x approaches 3 of x squared plus 2? That'll be the type of thing that we see a lot. Because my goal with these videos is to just give you guys really understandable information, I'm just going to give you the informal definition. What is happening to the y values as x gets close to some arbitrary number. So basically, what we care about is y. Our output is going to be y. That is what we are going to determine. And we're going to do that getting close to some arbitrary number. One of the biggest hang-ups I see from students on this is we don't actually care about what's happening at the number. What we care about is what's happening close to the number. Okay, so a really common example of this is a graph that looks something like this. Okay, so what I have is a positive sloped line, an open spot, and a negative sloped line. Okay, and then I have a spot right here. This is still a function because every x value has a given y value. But from the left, I'm approaching this open dot. From the right, I'm approaching this open dot. I don't actually care that this spot down here is lower. What I cared about is the fact that what's happening close to this particular x value. So I just wanted to throw that out there. We'll go into way more detail on that later in this video series, but that's where I wanted to start. All right, next thing. For a limit to exist, it must approach the same y value from both sides. Okay, so I'm just going to jump right in. This limit would exist because I'm going to the same, whatever this y value is, I'm going to the same y value from the right and the left. Examples of how a limit does not exist is if behavior differs. So on this one, the red line, I am getting closer to 4, right? My y value 4. Again, we care about y values. And on this one, I'm approaching 2. I'm getting close to the x or the y value of 2 from the black line. Okay, if we're talking about x equals 1. So that is what we call behavior differs from the left and the right because we're not going to the same y value. And again, for a limit to exist, it must approach the same y value. Another one is unbounded behavior. So if I'm just looking at this spot right here, I have a vertical asymptote. So unbounded behavior is another place where limits do not exist. And then the third one is oscillating behavior. This one's the least common of the three. But there are some functions that look kind of like this. Basically what ends up happening is they get close to a certain number, in this case 0, and they just totally freak out. So if you see that, the limit does not exist at that spot. One other thing that my students often have a hard time with is determining why and where these spots are interesting or not. We usually look at the interesting spots. We look at this oscillating behavior at x equals 0. We look at this vertical asymptote. We look at the line where the behavior differs. But it is worth noting, this limit right here at x equals 0 does exist. Okay? In fact, all of the limits along this red line exist. All of the limits along this black line exist. The only one that doesn't exist is this one that's in the middle. Okay, so I think that's always important to justify because, or to say, just so you know, we're usually looking at the interesting spots, but there's a bunch of boring spots where the limit does exist here. Okay, last thing, if you say if your answer to a question, the limit does not exist, DNE, you have to justify with one of these three reasons. Okay? You can't just say the limit does not exist. You have to tell me exactly why, so that you have that. So again, limits overview. This is said the limit as x approaches c of f of x. Basically, we care about y values, and if a limit is going to exist, it has to approach from the same y value from both sides. We have three ways it doesn't: behavior differs, unbounded behavior, and oscillating behavior. Thanks. I will continue with this video series and jump into L1 next.